Hello and welcome back. For this video we'll be discussing how to do multi-step equations. If you haven't practiced one-step and two-step equations, go ahead and try those first and then come back in. We're also going to include variables on both sides of the equation. First thing we're going to look at is the steps. There's three basic steps and you should start with the top and work your way down. So don't go to step 2 until you're finished with step 1. Now step 1 is real simple. It's simplify both sides of the equation completely, and do that before you move on to step 2. Now simplifying could be one of these steps here. You could do combine like terms, or you could distribute it to eliminate parentheses, then go back and do combine like terms. So step 1 really has multiple parts to it. You could also clear fractions like we have here, or we can clear decimals. That's not really necessary, but something that is important is that you cannot clear or combine things inside parentheses with things that are outside until the parentheses go away. So the parentheses have to be eliminated. So that's one of the things you'll see right here, D or B, which is distribute to eliminate parentheses. You typically like to do that as soon as you can. Once you're convinced that everything on the left and right hand side has already been simplified, there's nothing else to do, then you want to start to moving the variable all to one side, either all to the left or all to the right. And I do have a little hint here. And my suggestion is eliminate the variable that has a smaller coefficient. That way you avoid negative coefficients. And if you've done step 1 and step 2 right, by the time you get to step 3, which is isolate your variable, meaning get it by itself, and you will do that by applying the PEMDAS in reverse. So reverse order of operations is what you're talking about there. A little bit of information about this first is any equation that contains a variable such as 4x minus 5 equals 19 is called an open sentence. Any value of the variable that makes that open sentence true is called a solution. Equations that have the same solution are called equivalent equations, and that makes sense. And when we solve, we're trying to transform our starting equation into simpler and simpler equations, or equivalent equations, until we have a single variable by itself, and on the other side of the equal sign will be either a single numerical value or possibly an algebraic expression if you're not actually solving for one single number. Example 1, you can see here we already have variables on both sides. So I'm going to start with the first step, which is simplify both sides of the equation. Well, if you look on the left hand side, there's nothing to simplify. The right hand side, there's nothing to simplify. There's nothing you can combine there. So now we're going to step 2, which is eliminate the variable from one side or move the variable from one side to the other. And based on the little hint that I gave, the coefficient of x on this side is a negative 8. Whereas on the right hand side it's a positive 4. So I'm going to eliminate the negative 8x, and the reciprocal of subtraction is addition, or the additive inverse if you want to call it that, is plus 8x. And I have to do this on both sides, and this is called the addition property of equality, and technically those two things are equal to each other. What happens here is the 8x and the negative 8x becomes 0, and when you add that to 7 you get the identity of 7 plus 0, which is just 7. Bring down my equal sign, and then combine your 4x and your 8x through addition, and we have 12x. And the minus 17, we didn't touch that, so I'm just going to bring that down as well. Now I'm basically done with step 2. Go on to step 3. Step 3 says isolate the variable, so get x by itself, using reverse PEMDAS. So in this problem I have a multiplication by 12 and a subtraction of 17, so I'm going to undo the lower order of operation, which is the minus 17, using adding 17. I'm going to add that on both sides, so there's their equality of addition again. And this is going to give me a 0 on the right hand side, and then 12x plus 0 is going to give me 12x. And the left hand side, 7 plus 17, is just going to give us 24. At this point it's now down to one step. I want to eliminate the 12, or get rid of the 12. I want it to be 1x, not 12x by itself. So I'm going to divide both sides by 12, because x is being times by 12 up here. So to undo a times 12, you're going to divide by 12, but you have to do it equally on both sides. And we could refer to that as the division property of equality, even though it's really the multiplication property of equality using the reciprocal. So the left-hand side, 12 divided by 12 gives us 1, and 1 times x is just x. Again, that's another identity for multiplication. And the left-hand side, 24 divided by 12 leaves us with 2. Now, if you think that that's your answer, you are supposed to take this 2 and substitute it back up into x here and x here, and check to make sure it actually works. Example number 2, step 1, remember, is to simplify both sides. Well, the right-hand side, there's nothing I can simplify there. However, on the left-hand side, I have a 3 on the outside, which means I can distribute the 3 to this number, and I can distribute to this number. Okay, so I'm going to distribute to the first one. 3 times 2x is going to give us 6x, and then 3 times the negative 3 is going to give us a negative 9. So now I have eliminated parentheses. Bring the rest of your problem down. And I've technically finished step 1. There was only one thing I had to do to simplify. Now I'm going to go to step 2, which is remove one of the variables from one side or the other. And the 4x is a smaller coefficient than the 6. So 4 is smaller than 6. So I'm going to eliminate the 4x's by minusing 4x from both sides. And that's an example of the subtraction property quality. It's really the addition property with opposites. So the right-hand side, that gets me 0. 0 plus 7 is going to leave us with 7, and that's the identity of addition. The left-hand side, 6x's take away 4x's, leaves us with 2x's. And the minus 9, I didn't do anything with it, so I'm just going to bring it down. So I now finished step 1, and I finished step 2. Step 3 is to isolate this variable, x, using reverse PEMDAS. So I have a times and I have a minus, so I'm going to undo the minus first. And to undo minus 9, we're going to add 9 to both sides. Addition property of equality. This becomes 0, and 0 plus 2x is identity, leaving us with 2x. And 7 plus 9 just simplifies out to 16. Now to undo the times 2, right here, we're going to divide by 2, but I have to divide both sides equally because that is the division property of equality. So 2 divided by 2 gives me 1. 1 times x is identity again, that's x equals, and then 16 divided by 2 simplifies into 8. Example 3, we have a multiply of 1/4 on the outside of our problem on this left-hand side here. And there's actually 2 ways I can deal with that. Number 1, I can eliminate the 1/4 by multiplying both sides of my equation by 4. So if I put brackets around these and times by 4, timesing by 4 here and then times by a 4th here cancel each other out to a 1, which leaves you an identity, and 16x plus 60 comes out. Or this particular scenario here, 1/4 will clear itself by distributing. So I'm going to go ahead and distribute. So 1/4 times 16 will end up giving me 4, and then the x comes down with it. And then 1/4 times 60 will leave me with a positive 15. The left-hand side, there's nothing to combine or simplify, so I'm just bringing down 9x minus 5. So now I've completed step 1, which is simplify both sides. Now move on to step 2, which is eliminate one of the variables from one side or the other. So I'm going to eliminate the 4x because it has a smaller coefficient. And to undo a positive 4x, I'm going to minus 4x, or use its additive inverse. So this becomes a 0, and 0 plus 15 leaves me with 15, so that's identity of addition. The left-hand side is 9x minus 4x, which will leave me with 5x. And the minus 5, I didn't do anything with it, so I'm just going to bring it down. Now I'm done with step 1 and step 2, and step 3 simply says isolate the variable using reverse PEMDAS. And you might notice that the last step here always seems to be a 2-step problem, which means the first thing you're going to do will be the plus or minus that's here, and this last thing you're going to undo is the multiplier divide that's there. So I'm going to undo the minus 5 by adding 5 to both sides. And this will give me a 0. 0 plus 5x is 5x. That's an identity again. And the right-hand side, 15 plus 5 is just simplified into 20. So I substitute that with a 20. The only thing left to do is get rid of the times 5. Well, to undo a times 5, you're going to divide by 5. And I'm going to divide equally on 5 on both sides so that the 5's become a 1. 1 times x is x. And the right-hand side is 20 divided by 5, which will give me 4. Example 4. The left-hand side here appears to be completely simplified. 4a and 3 do not have any like terms, so I'm just going to bring them down. 3 minus 4a. And the right-hand side, I can take my 5 and distribute it here. So 5 times a will give us a 5a. And 5 times the negative 3 will give me a negative 15. And I write that as minus 15. And I'm pretty sure that's all I can do with step 1. There's nothing else I can combine or simplify. So now I'll go into step 2, eliminate the variable from one side or the other. The left-hand side has a negative 4 for its coefficient. So I'm going to undo or eliminate the negative 4a by adding 4a to the left, but I have to keep my equation in balance, so I'm going to add 4a to the right, and those are equal. And negative 4a plus 4a gives me 0, and 0 plus 3 will give us 3. That's an identity of addition. The right-hand side, 5a plus 4a leaves us with 9a, and the minus 15, I didn't touch it, so I'm going to bring it down. And now I'm done with step 1 and step 2. Step 3, isolate the variable a using reverse PEMDAS. So I'm going to get rid of the 15 first. So minus 15, the opposite of that would be plus 15. So I'm going to add 15 on both sides. So the additive inverse of negative 15 is positive 15, and I treat it just like a plus sign. And negative 15 plus 15 zeroes out because they're additive inverses, and that will leave me with 9a. So 9a plus 0 is 9a. And the left-hand side, 3 plus 15, I can just substitute that with 18 or simplify it to 18. And the last step here is to get rid of the times 9 on the right-hand side. So I'm going to divide by 9 on both sides. Properties of quality are important. The 9s will simplify to a 1. 1 times a is a, that's identity. And the left-hand side, 18 divided by 9 leaves me with 2. Example number 5. We have a 1/5 on the outside of my parentheses. Now I do want to simplify by eliminating the parentheses. In a previous example, I was able to distribute the fraction, and the fraction itself cleared from the problem. However, if you look inside the parentheses here, there are no numbers that are going to divide nice and neat by 5 by distributing a 1/5. So I'm not going to use the distributive property to eliminate my 1/5 or clear my fraction. I'm actually going to multiply both sides of my equation by the least common denominator of 5. So I'm going to clear my fraction is what I'm doing. And notice how I put the brackets around the whole thing on the left, which means I'm going to put the brackets around the whole thing on the right. So this is 5 over 1. And when I do this calculation, when I take this 5 and I times it by 1/5, that becomes 5 over 5, which is 1. And that 1 will end up distributing to both of those. Do not take the 5 on the outside and distribute it inside additional parentheses. That's a common mistake that some students make. So once you've made the number out here 5 times larger, you don't have to make everything in here 5 times larger because you've already multiplied on the outside by that amount. So 5 times 5, or 5 divided by 5 will give us 1. So that 1 now comes on the outside, x plus 3. So this is 1. And the left-hand side, I'm going to go ahead and distribute the 5 right here. That will give me a 5x. And distribute the 5 times the negative 5, and that will give me minus 25. Now on the left-hand side, we have a 1 out in front, and 1 times anything is identity, which means I don't really need the 1 or the parentheses. So I'm going to drop the parentheses and bring the x plus 3 on the outside. So that's just an extra step. And now I've simplified and combined everything on both sides. I'm going to step 2, so eliminate the variable with the smaller coefficient. And the coefficient over here on this x is actually a 1, and it's smaller than the 5 on the right. So I'm going to eliminate 1x from the left, and I'm going to eliminate 1x from the right to keep this equation in balance. X minus x gives you 0. 0 plus 3 is going to give you 3. That's identity of addition. And 5x minus 1x leaves you with 4x. And then the minus 25, we did not do any work with it yet, so we're going to just leave it right there. Now we're done with step 1 and step 2. Now we're just going to do reverse PEMDAS, so I'm going to get rid of the 25 first, so that's a minus 25. So to undo that, I'm going to add 25, and I'm going to do that equally on both sides. When you start eliminating things from one side of the equation, you have to eliminate an equivalency on the other side to keep your equation in balance. So this ends up being 4x plus 0, which will give me just 4x. That's an identity. And the left-hand side will give me 3 plus 25, which is going to be 28. And now I only have to divide by 4 on both sides because I want to eliminate the 4 and get a 1. I want this to become a 1x, or just x. And then 28 divided by 7 is 4, so we can see that x should equal 7. Example number 6, we have a multi-step where we have multiple parts in the numerator and a single number in the denominator. So basically the left-hand side of my problem, this side right here, is one big fraction. And again, I don't want to have to deal with fractions if I can avoid it, so I'm going to clear the fraction. And the way I do that is I would multiply both sides of my equation by whatever my greatest common denominator is, or sorry, least common denominator is, which would be 4. So I'm going to multiply both sides by 4. And the right-hand side only has a single number, so I'm just going to do 4 times on that side. Now, one thing you want to be aware of is this 4 that's on the outside here is going to be simplified with the 4 that's on the bottom. You're not actually going to take this 4 and distribute it with each of these. You might remember what I said earlier is when you have multiple parts in the numerator, you got to treat that like a big group. So there's like another grouping symbol in there. And if I were to take that entire numerator and then times it by 4 just to turn right around and divide it by 4, that's like I didn't do anything at all to it. So the 4's reduce themselves to 1, and what comes out of the numerator is 5k minus 3 times k minus 2. So I've now cleared the fraction on the left-hand side, and I've simplified. And the right-hand side, negative 6 times 4, I'm just going to write that as the equivalency of negative 24. Now, I'm not done with step 1 because I still have some things on this side that I can do. I can distribute that negative 3 to get to the k, and then, of course, I got another k on the outside I can eventually combine it with. So I have at least 2 more steps to go before I can move on to step 2 of the multi-step process. So I'm going to distribute. Now, you got to be careful here. You're going to distribute. I'm going to put this in blue. You got to distribute not just the 3, but the negative 3 to both of these terms. So I'm going to bring the 5k down because I'm not distributing with that one. So negative 3 times the k is going to give me a negative 3k. And then negative 3 times the negative 2 is going to give me a positive 6. And then I bring down the right-hand side because I did not change it at all. Now, I still have like terms here. I shouldn't move things or eliminate things from one side or the other until I've combined everything on one side and the other. So I'm going to combine my 5k and my 3k. So 5k minus 3k leaves me with 2k plus 6 equals negative 24. So now I've simplified everything. I don't have a variable on both sides, and you'll see I actually have a two-step problem left over. So in order to continue solving, I'm going to eliminate the 6 first. So I'm going to minus 6 on both sides, which will undo the plus 6 here. And that gives me a 0. 0 plus 2k is an identity for 2k. So bring the 2k down. And then on the left-hand side, negative 24 minus 6 is going to leave us with negative 30. You may need a calculator for that. And then the last thing we do is to eliminate this 2 by dividing 2, because 2 is multiplying with k, so to undo that, you're going to divide by 2 on both sides equally. And now we're left with k equals, because 2 divided by 2 is 1. And the right-hand side, we have negative 30 divided by 2, which is negative 15. Numbers 7 and 8. These are special equations. These are scenarios that you will probably see in some of the work you do, and you need to know how to interpret them. So I'm just going to go ahead and start simplifying here. So the left-hand side, I'm going to bring the 3x down because I don't have anything to combine with yet. Now what you may want to do out in front of this parenthesis is put a 1 there, because what you're really going to do is distribute a negative 1 here, which will give you a negative x, or negative 1x. And you're going to distribute the negative 1 here to the negative 5, which will give you a positive 5 equals, and I'm going to go ahead and distribute the 2 on this side at the same time. 2x, and then 2 times the 4 will give me 8. Now the left-hand side, I can combine my like terms here. 3x minus 1x leaves me with 2x. I have plus 5 equals 2x plus 8. And then try to eliminate my variables from one side or the other. Well, you see they're both equal, so when I try to eliminate my variables, I'm going to subtract 2x from both sides. This is 0. 0 plus 5 is 5. And this is 0 also. And 0 plus 8 is 8. Now you'll notice there's no more variable left in the problem. What we want to ask ourselves is this expression true or false? If that answer is true, then what you have is something called an identity. If that answer is false, then there's no solution. Now we can clearly see 5 does not equal 8. Therefore, we say this problem has no solution. So anytime your variable drops out of the problem and the remaining equation is not true, we say that the equation has no solution. Now compare that to example number 8. You'll notice the only thing that's changed here was the negative 8 here. So when I distribute my negative 1, I have 3x, and then I get a negative 1 times x is negative x, negative 1x, and then negative 1 times a negative 8 gives me a positive 8. And the right-hand side, 2x, 2 times x is 2x, and then 2 times the 4 is going to give me 8. And then I combine my like terms here, and I have 2x plus 8 equals 2x plus 8. And at this point, some of you are starting to realize that, oh, these are exactly the same. So if I tried to eliminate my variable from both sides, this is 0, this is 0, leaving 8 equals 8. In this scenario, we'd say that that is actually true. So what that means is no matter what number I put in up here for x there, or there, the left-hand side will always equal the right-hand side. Now this has a special name. When that scenario is true, where the variables drop out and the equation left over is still true, we call that an identity.